All right, so y'all, this final exam is going to cover material we've learned the whole year, okay? So we're going all the way back to the fallacies now. So question 1 says, identify the fallacy in the given argument. Each of my brother's 3 dogs has fleas, therefore all dogs have fleas. So we want to know if that's circular reasoning, false cause, hasty generalization, or straw man. So this one is definitely what you would call hasty generalization. Okay, because you're making an assumption that all dogs have fleas just because the brother's 3 dogs had them, and that might not be true for everybody, okay? So I'm gonna let y'all try this one. So y'all can chat if y'all want to on this one, or even tell me, unmute yourself and tell me. Identify this fallacy. A television commercial shows 2 people who fall in love while wearing a certain pair of blue jeans. So y'all think that's appeal to ignorance, appeal to emotion, hasty generalization, or limited choice?
Appeal to emotion.
And so let me tell y'all what I would focus on if I was y'all. The part about the love. So what y'all think?
Appealing to emotions.
Oh, my chat's quiet today. All right, y'all, how about that one being appeal to emotion, right? Just like we were talking about the Michelin tires. They show a baby sitting inside them tires on that commercial because you love your baby, so you're going to buy Michelin tires. So they're trying to apply to your emotions.
Mr. Ruffin?
Right. Then we had to do conversions. So this one wants me to convert 12 feet to inches. So remember, we know our conversion is for every 1 foot. 1 foot equals 12 inches. So now we're starting with 12 feet. So this is where we were drawing in the little lines with the boxes. And we need to cancel feet. So the feet need to be on the bottom. So every 1 feet is equal to 12 inches. So your conversions are given, but you got to put them in the right place. You need them to be in the place so that you can cancel out the units you're converting out of, and it leaves the units that you're converting into. So all we really got to do is multiply 12 times 12, and that would give me 144, and my unit would be the inches, because that's the unit that's left after I crossed out the other units. So y'all come over here and put your 144 and be done. All right, so sort of like the same thing here. A commuter train travels 41 miles in 29 minutes. What is its speed in miles per hour? So we're not changing out of the miles, so we don't have to worry about that one, but we are turning our minutes into hours. So we got a conversion that says for every 1 hour, that equals 60 minutes. So that's the only unit I got to convert over, okay? So I start with my 41 miles in 29 minutes. Okay, so it's sort of like miles per hour. The miles go on top and the time goes on the bottom on these, okay? So then we draw our box. So we need to turn the minutes into hours. So since minutes is on the bottom here, and we need to cancel the minutes, the 60 minutes will go to the top, and the 1 hour goes to the bottom. So that way these minutes cancel and we're left with what we needed, miles per hour. Now, on this one, since the 41's on top and the 29's on bottom, we need to divide that. Anything on top divides by anything on the bottom. And we're going to multiply times the 60. So usually what I do on that one first is I multiply everything on top. So on top, I got 41 times 60. That's going to give me 2,460. Divide that by the 29 because the 29 is on the bottom. So let's see what they wanted us to round it to. It says round to the nearest tenth. So that means 1 decimal place. So I got a 84.82. So the 8's going to stay at 8. So I'm going to keep that 84.8. And now my units will be miles on top per hour on the bottom. And see, they'll give you a choice over here. Y'all click the one that had the miles per hour. And then up here, you would just put your 84.8. Okay. So be careful. You got to read what they want right here. Round to the nearest 10. Okay. Paragraph 5 says carry out the indicated unit conversion again and round the answer if appropriate. So there are 8 ounces in a cup, 4 cups in a quart, 4 quarts in a gallon. Using a chain with these conversions, convert 6 gallons into ounces. So we're starting with the 6 gallons and we're going to make some boxes. So I don't have a conversion from gallons to ounces. So I do have a conversion from gallons to quarts. So since I want to cancel out the gallons, I got 1 gallon down here equals 4 quarts. So now the gallons cancel. So I don't have a conversion for quarts to ounces yet, but I can go from quarts to cups. So I need to cancel the quarts. So for every 1 quart, they said that was 4 cups. So y'all look at that. The quarts now cancel and we're left with cups. So now I can go from a cup to ounces because I know that conversion. So for every 1 cup, it says there is 8 ounces. So now our cups cancel. All that's left on bottom is a bunch of 1s. So we don't even got to worry about the bottom. So what we need to do is multiply every one of these numbers on top, and then we'll have our ounces. So y'all, here we go. We got 6 times 4 times 4 times 8. So that gives me 768. And that was going to be in ounces since that's the only unit we had left. So hopefully, yeah, we got that for B. Okay, so this is going way back to test 1 material, okay? All right, y'all got any questions on that page? All right, so next page. So more conversions. Carry out the indicated unit conversion. Round our answer if appropriate. So it says use a chain of conversions with familiar measures of time to convert 4 weeks into seconds. So we're starting with 4 weeks. And we're going to turn that into seconds. Well, I don't have a weeks to seconds conversion that I'm familiar with, but I can go from weeks to days. And I know that every 1 week is 7 days. So now I can cancel the weeks and my units are in days. I don't know a conversion for days and seconds right off the bat, but I can do days and hours. So I do know that for every 1 day is 24 hours. So now the days cancel and I'm in hours. So you could convert from hours to seconds if you know how many seconds is in an hour. But I'm going to go to the easy one that I know. I know that for every 1 hour, that is 60 minutes. So now my hours cancel and I'm left with minutes. And now we know what every minute is 60 seconds. So for every 1 minute, that is 60 seconds. So the minutes cancel and I'm left with my seconds. So y'all, once again, on the bottom is a bunch of ones. We don't need to worry about them. We just need to come in here and multiply all these numbers on top. So 4 times 7 times 24 times 60 times 60 gives me, looks like 2,419,200. And that is now in seconds because that's the only unit we had left. So y'all, look at that. There we go for number C. So when we work these out good, the answers are going to be right there for us, right? So if we work one and it's not there, then we know we sort of got to figure out where we made a mistake. All right, so let's see what this says. $1 US is worth 12.73 Mexican pesos. How much would 120 US dollars be worth in Mexican pesos? So we're going to start with this 120 US dollars. And we're going to turn that 120 US dollars into pesos. So the conversion right here, they said, hey, $1 US is worth 12.73 pesos. So we want to cancel the dollar. So for every dollar US, you get 12.73 pesos. So our US cancels. We're left with pesos, and that's all we needed to do. So we take our 120 times 12.73, and that gives us 1,527, and that'd be 0.60. So they're adding a zero to make it look like cents. Okay, so not bad. Those conversions aren't bad if you just go by what they're giving you on these things, okay? Look at this one. This one says you return from a trip with 300 Canadian dollars. How much are your Canadian dollars worth in US dollars? And they're giving us the exchange rate right here. So we're starting with Canadian dollars. So we're wanting to know how many US dollars per Canadian dollar. We'd use this conversion. And looks like the Canadian dollars are worth a little bit less than the American dollars, right? Oh, my neck, boy. All righty, y'all. So here we go. We're starting with what? 300 Canadian dollars. Now, if I want to cancel the Canadian dollars, for every 1 Canadian dollar, it tells us you get 1.054 US dollars. But we want to go this way, right? Because we said we want to find how many US dollars we get per Canadian dollar. And since we're starting with Canadian dollars, that's one I want to use. So that gives me what? 0.9484 US dollars. So what this basically is telling us is that the Canadian dollar is worth less than the American dollar. So if you start with Canadian dollars, you want to multiply by what percent of the US dollars it equals to find its value. So what we need to do is take our 300, multiply by our 0.9484. Now, if you were starting with US dollars, I'd have used the other conversion because it takes more than one Canadian dollar to equal an American, okay? Well, those are tricky to explain, right? But notice we get 284.52. So that one wasn't even actually on here, and we're rounding to the nearest cents. So I would make that exactly what I got, 284.52. So y'all remember, if starting with Canadian, you want to use this one, okay? If I start with American, converting to Canadian, then I would use this one. So if starting with US dollars, then you would pick that one, okay? All right, so y'all remember this stuff, scientific notation. They're giving me scientific notation, but they want me to write it in ordinary notation. So take your number, 2.5764. Now, this exponent tells me which way to move the decimal. If the exponent's positive, I move right. If the exponent's negative, you would move left. So since the exponent's positive, we move right. Now we got to move right 6 units. So here we go. 1, 2, 3, 4. I need to add a 0, 5, add a 0, 6. So my new number will be, oh, what's that look like? 2,576,400. Look over here. Answer A, 2,576,400. Okay, so positive exponents, move the decimal right. Add zeros when you need to. All right, this one wants me to find the monthly cost. So this is where I added everything up by the year, and then we'll divide that by 12 to get the monthly cost. So it's $300 a month for food. So we would take our 300 times 12, and for the total year, let's see what that equals. That's 3,600. Semi-annual health insurance premium of 1,400. So that means 1,400. Remember, semi-annual means twice. So 1,400 times 2 would give us 2,800 a year for that part of it. And then an annual car insurance premium of 550. So annual means just once. So that would just be what, 550 there. So add all them up to get our yearly amount. Then we'll divide that by 12. So 3,600 plus 2,800 plus 550. All those added up to 6,950. And remember, that's a year. So now we want the monthly. So we'll take that 6,950 and divide that by 12. So 6,950 divided by 12, y'all, gives me, so they want to round to the nearest dollar. So that means no decimal places. So since my 9 has a 1 after the decimal, we leave that at 9. And we need $579. So let's see, we have that on B. So y'all, it's been about what, 12 weeks since y'all messed with these kind of questions, you know it? So y'all good on that page. So a lot of conversions, but we're giving you the conversions, so we don't really have to use the conversion sheet. Okay, so, all right, let's see, how am I doing on time? So we're doing pretty good. Like this one says, find the monthly interest payments in the situation described. Assume that monthly interest rates are 1/12 of annual. So it says Ashley maintains an average balance of $900 on his credit card, which carries an annual interest rate of 24%. So they're telling us here that the monthly interest is 1/12 of the annual. So if the annual is 24%, we take that 24% and divide by 12 to get the monthly percent. So when you take 24% and divide by 12, you're left with 2%. Now, we want to know what 2% of 900 is. So we take the 900, multiply by 2%, but remember, when you multiply, you got to turn that 2% into a decimal. So you move the decimal left twice. So we get a 0.02. So we want to multiply the 900 times 0.02. And that gives me $18 a month. So, and we're just looking for the monthly interest. So we come over here and choose A. So whatever else is on this bill is not paying toward the interest, it's actually paying toward the bill, okay? Alrighty, so this one says use the compound interest formula for compounding more than once a year to determine the accumulated balance after the stated period. So this would be a good formula to have handy when you're working my final. But the compound interest formula was A equals P times parentheses 1 plus the APR divided by N, close parentheses, and then your exponent was the N times Y. N is the number of compounds. APR is the annual percentage rate. P is the starting amount or the principal. And then Y is the years. So they're giving us what we want. So we come over here. Our starting amount is at $2,000. That's going to be times 1 plus. Our APR is 4%, but we got to turn 4% into a decimal. So I'll move the decimal left twice. So that's going to give me a 0.04. So I'll put 0.04 on top. That's going to be divided by N, which is the number of compounds. This one has monthly compounding. That means 12 times a year. So we're dividing by 12, closing the parentheses, and then we do the exponent 12 times Y. Y is the years. Well, they're giving us that right there. That was 6 years. So that 12 in the exponent is going to get multiplied by 6, okay? So P was the 2,000. APR, they actually said was 4%, so I didn't even need to put that letter there because they gave it to us, okay? All righty, so all that's ready to be punched into our calculator, and hopefully we get one of these four numbers, right? All right, y'all, so here we go, 2,000 times parentheses 1 plus 0.04 divided by 12. Close your parentheses. Now to do the exponent, hit that little V, upside down V, we call that a caret. Hit that. And the exponent was 12 times 6. So we're going to hit enter now. And we got 2541.48. So we'll see how they want us to round that in a second. All right, so we come over here. Yeah, we got that exact answer. I rounded to the nearest cents. In a money problem, they're either going to have you round to the nearest dollar or to the nearest cents. That's how I knew I didn't have to write that other part, okay? So look over here at A. And we're done with that. So y'all write this formula down because that's a good one. That's for compound interest formula. Okay. Oh, here's one we work the other way. You want to have $100,000 college fund in 20 years. How much we have to deposit now in an account with an APR of 5% and daily compounding. So daily compounding will be my N. They're telling me that's my APR. I want to end up with the 100,000. So that's actually going to be the amount you want to end up with. 20 years will be my time or my Y. I'm looking for the actual P, the amount I would have to deposit now in order to have that ending amount of 100,000. So this is where we had to use the other formula, where we have to find the principal, which is the starting amount, remember. So principal equaled our A divided by parentheses 1 plus APR divided by N to the exponent N times Y. Y'all, I better write APR by the ones that I had APR at, okay? So up here, that was actually APR, and we was finding that A. So down here, I'm just gonna use APRs because we're solving for things using those A's. So A is the amount you want to end up with. So we take that and divide by what I got down here in parentheses. That way we'll find our principal, which is the amount you have to start with. So what is the A? 100,000 divided by parentheses 1 plus APR is 5%. Remember, turn that 5% into a decimal by moving twice. So we get a 0.05. In daily means what, 365 days in a year. So that'd be divided by 365. And then the exponent would be 365 times the number of years they gave me. And that was 20 years. Okay, so when you know how much you want to have in the future for a house, for college, for a car, and you find a place that has a certain interest, you can use formulas like this to tell you what you need to start with in order to make that happen. Actually, that's what a bank will do if you wanted to make that happen at a bank, you know, and get a savings account with, say, 7-8%. They would figure out what you needed to start with. All right, y'all, so our formula, 100,000 on top. That's going to be divided by parentheses 1 plus 0.05 divided by 365. Those parentheses, and then the exponent, hit the little caret key. That's going to be 365 times 20. All right, so the main thing is when you're putting that in, make sure you hit that exponent key, okay? So y'all hit enter. That gives me 36,790. So $36,790.46. So let's go see what they got. So y'all, that'd be A, right? 36,790.46. So that's how much money you'd have to put in that account. And after 20 years, your $36,000 would turn into $100,000. But that's not bad if you wanted that. And that's only at what, 5%, okay? Now let's see what they got here. Suppose you start saving today for $11,000 down payment that you plan to make on a condo in 6 years. Assume that you make no deposits into the account after your initial deposit. The account has monthly compounding and an APR of 3.6%. How much would you need to deposit now to reach your 11,000 goal in 6 years? So y'all, that sounds like the same thing, right? We're looking for the starting amount now so that we can have $11,000 in 6 years. Okay, so and it has monthly compounding. So monthly compounding is my N. APR of 3.6%. That would be my amount I want. And then years is my time. Okay. All right, so let me see. We got our formula right here. So we're looking for that principal again. So our amount is 11,000. We want that in 6 years. We got our parentheses 1 plus APR is 3.6%. So we got to move that left twice. So y'all, that's going to be a 0.036 for our APR. Divided by N, what do we say, monthly compounding. So there's 12 months a year, so that'll be a 12. And then that's 12 times the years, which was 6. So that's that NY. So whatever you divide here by is the first part of your exponent when you're multiplying, okay? All right, so once again, we should get one of these 4 answers. So here's our 11,000 divided by parentheses 1 plus 0.036 divided by 12. Make sure you close in parentheses. Hit the caret key for the exponent. And the exponent was 12 times 6. All right, y'all, we hit enter. I get what? 8865. That's going to be 95 cents. So 8865.95. All right, so let's see if that's over here. 80, what did we say? 8865. So that'd be C this time. All right, y'all, let me straighten that up this a minute. All right, so this says calculate the amount of interest you'll have at the end of the indicated period. You invest $700 in an account that pays simple interest of 4% for 3 years. So simple interest had an easier formula. Simple interest was A equals P times parenthesis 1 plus APR times or Y. APR is a percentage rate. Y is the number of years. P is the starting amount or principal. A is the amount in the account, okay? All right, so let's see. They gave us everything. We're starting with $700. Multiply that by parentheses 1 plus my APR. Well, that's 4%. we're gonna have to move that left twice and add a 0, so we get a 0.04 times our years, which was 3. All right, y'all, so let's push that in, 700 times parentheses 1 plus 0.04 times 3 close parentheses. All right, looks like they're rounding to the nearest cents. So we got what, 784? Now look here. We want to find the amount of interest we found at the end of that period. So our account went from 700 to 784, but now we want to just find out how much of that was interest. So we take that ending amount of 784, subtract what we started with, which was 700, and that gives us $84 of interest. So y'all, they just rounded it off like the nearest cents. So 84.00 is the same as our 84. Okay, so remember, when you get that amount, subtract that beginning amount to get that 84, okay? Because that's all they wanted us to figure on this one, is what was the amount of interest we had, okay? All right, y'all, so let's see, any questions on this page? So remember these formulas, these are good formulas to have. Your simple interest formula here. This formula is right here we use to find the amount of principal we would need to get an ending amount that we wanted. Up here was the compound interest formula. It finds the amount in the account at any time. You got your starting amount and so on, okay? All right, so I have all my little formulas on a sheet right next to me for this test. All right, y'all, so let's see what 16 says. We just got to answer this question. The blank in financial formulas is the balance upon which interest is paid. Remember, what was our starting amount always called? We called that our principal. So the principal in financial formulas is the balance upon which interest is paid, okay? All right, this one says blank is interest paid only on the original principal and not on any interest added at later dates. So this one is simple interest. Remember, compound interest is when we did it semi-annually, monthly, quarterly, all those type of words, okay? Nice, y'all good? All right, the blank is the annual percentage by which a balance increases in 1 year. So that was your annual percentage yield. So that was B. Remember, that's the one where we had to use the formula to find out what the account made in a whole year. And then we subtracted the amount in the account, and that gave us that percent difference. So that was how we was finding that APY back in the day. All right, what am I on, number 19? What is continuous compounding? How does the APY for continuous compounding compare to the APY for, say, daily compounding? Explain the formula for continuous compounding. So that, let's see. I'm trying to see which. So continuous means you're always compounding it, right? And if you're always compounding something, it can be an infinitely many compounds. So I'm seeing which one has that. So this would be C, y'all. Compounding infinitely many times per year is called continuous. The APY for continuous compounding is only slightly larger than the APY for daily. And then the formula for continuous compounding is a special form of the compound interest formula. So we would definitely go with C. Continuously means infinitely. If they just said compound, then you would have went with D, because it would be at least once a year, okay? So you just gotta, they're just sort of seeing if you got an understanding of all that stuff we were doing back in the day. All right, y'all, let's see what this one says. A sample statistic and margin of error are given. Find the confidence interval likely to contain a population parameter of interest and answer the question. So remember, when we found confidence intervals, we took the data and we added and subtracted that margin of error. So 10 years ago, 17% had no health insurance. This year, a poll revealed that 20.1% were without insurance. The margin of error was 1.8%. Find a confidence interval, which is what we're going to find using the 20.1% and the 1.8. So for our left side, we need to figure out what 20.1 minus 1.8 equals. For the right side, we need 20.1 plus 1.8 and see what that equals. So y'all, here we go. So 20.1 minus 1.8. The left side is going to be 18.3. The right side, we're going to add 20.1 plus 1.8. That gives us 21.9. So the question says, can we conclude that the percentage without insurance has increased from 10 years ago? Well, y'all, 10 years ago, it was 17%. My left endpoint, which is my lowest percent, was 18.3. So since 18.3 is definitely higher than 17, we can conclude without a doubt that it has increased. So that would be yes. So we need intervals from 18.3, which looks like B, to 21.9. Okay, so take the data you're looking at for today, add and subtract that margin of error, and there you go. So you look here, 21 is the same thing. Find the confidence interval and then answer the question. So following the Republican National Convention, a poll of voters in a central Illinois community showed that 56.2% would choose the Republican ticket to win over the Democrat ticket, no matter whom the Democrats chose for vice president. The margin of error was 5.4%. Should the Democrats expect to lose central Illinois? So what I'm looking for when I do my interval, if my lowest value is at least 50% or higher, then that means I would have the majority of the votes and the Democrats would have to worry, right? So we need to find our interval. We got 56.2. We're going to subtract 5.4 for our left side. 56.2 plus 5.4 for my right side. All right, so 56.2 minus 5.4 is 50.8, which is higher than 50. So that means no matter what, since our smallest percent was 50.8, that means that's the majority and the Democrats have to worry. Now let's find the right side. 56.2 plus 5.4, we get 61.6. So we need to find 50.8, looks like B, and then that's going to 61.6. And they answered yes, like we said. Okay. All right, we're trying to get a few more of these knocked out for today for sure. Identify which type of sampling is used in the example below. So number 22 says, to avoid working late, the quality control analyst simply inspects the first 100 items produced in a day. So he just snagged the first 100. So y'all, that would be convenience. Because it was convenient to him, right? He just had to snag those, take his samples, and be done. Same thing for number 23. The sample consists of every 20th student who leaves the library. So I'm not doing every student, I'm picking every 20th student. So when you do something like that, that would be what we call systematic. You're using a system to pick your vote, your samples, okay? All right, let's see what I got. 24 here. In order to answer the question, which of the following types of study would be most appropriate? Does the new medication relieve depression? Well, when you're doing something like that, drug companies can influence the lab techs. So you don't want them lab techs or the experimental scientists to know which one is the placebo or which one is the med. You don't want the clients who are participating to know who's getting the placebo or the actual meds, because you definitely need to test that medicine, right? So you're doing an experiment and it's going to have double blinding. Right? In order to answer the question below, which of the following types of study would be the most appropriate? In which of these 4 soil types would the plants grow fastest? So you're still doing a experiment because you're planting and you're looking at the soil. But you don't really need blinding, because on this one, you can look at the results, right? You can tell how they're growing. So there's no way to blind the plants. There's no reason to blind these experimenters because you're looking at the results. So on that one, I said that would be experiment without blinding. So we did want blinding on this one because you're looking at medications for depression, okay? All right, remember, qualitative and quantitative. Qualitative was stuff like colors, rating systems like ABCs and stuff like that. Quantitative is numbers that I can take averages of and find means of and modes of and all that fun stuff, okay? So the population of a town. Well, that's definitely a number, so that's definitely going to be quantitative. Qualitative is the ones that sounds like describing things and stuff. Also, look here. The movie critics' ratings of the new movie on a scale of 0 to 10, where 10 is the best movie and 0 is the worst movie. So that's just a rating system. So when numbers are used as a rating system like that, they are what we call qualitative. Because it's just based on somebody's view of a movie, right? It's not really finding averages of stuff like ages and salaries and fun things like that. Look here, quantitative or quantitative. The marital status of individuals. Well, whether you're married or unmarried, I mean, that's good to know, but I can't do anything with that. I don't have any numbers. So since I don't have any numbers I can crunch, that's not really quantitative. That would be another one of the qualitative, okay? So look at differences up here. I had population. Population, it definitely can change based on the size of the cities and things like that, okay? These are just describing stuff, rating stuff, okay? All righty, y'all, let's see. Let's knock out a little bit more of this. That way, Monday night or Monday afternoon, we won't have as much to do, okay? I think altogether, this thing was like 52 questions. Now, I did send a video with all 52 worked out in it. But that's been changed a little bit to this new one. Because we took out 1 or 2 questions, I think, and replaced them with the new ones that you're going to see here. So definitely be back Monday for the finish of this, okay? So now, find the mean. Well, the mean was the average. So to find the average, you're going to add all them together, divide by 5. So let's see, 17 plus 17 plus 14 plus 17 plus 15. Divide all those by 5 because we had 5 scores. So that's all going to equal 80. And then take that 80 and divide by 5. You get 16. Now, if you did this all in one step on the calculator, put that in parentheses, and it'll do it all in one step. But notice when I did it, I added that comp before I divided. Okay, so we got 16. And remember, the average has to be in between the lowest number and the highest number. So if you get any other number between something between 14 and 17 for the average, you know you definitely made a mistake in there, okay? A store manager kept track of the number of newspapers sold each week over a 7-week period. The results are shown below. Find the median of the papers. Well, the median is the middle. So let's see, these are not in order. So I'm going to put my numbers in order real quick. 82, 95. What's next? 194. 218. 241. 249. And then 294. So I got 1, 2, 3, 4, 5, 6, 7. So when you're finding the median of an odd number of data, it's always the middle number. So I got 1, 2, 3, 4, 5, 6, 7. So it's going to be the middle number, which is 218. If it was an even number of data, then you have to add the 2 middle numbers together and divide by 2 to get the median. All right, find the mode for the given data. So the mode is the one that happens the most. So let's see, -20, -42, -46, -42, -49, -42, -49. Well, y'all, it looks like the one that happens the most is that -42. So my mode is -242. All righty, so let's see. On this one now, it wants to find a standard deviation. I'm going to do that in my calculator. We've done it by hand. But remember, that's a long process doing this one by hand. Now, if anyone wants to see this by hand, when we come back Monday, since this will be my last question I do, when we come back Monday, I will do this by hand, okay? So I'm going to find a standard deviation. So remember, I hit second stat to get my list. So I'm going to go to L1 and hit enter. Whoops, hang on. Hit stats. So So go all the way back. So let's go all the way back. Hit stats. It's already on edit highlighted, so hit enter. So my L1 is blank. If you got any data in your L1 already, you're going to arrow up till your L1's highlighted, and then you're going to push the clear button, and it'll clear it out when you come back down. All right, so in L1, I'm going to put this data. I got 50, enter, 10, enter, 39, enter, 22, enter, 11, enter, 54, enter, 75, enter. Make sure you hit enter after every single number, even that 75, okay? So that they all show up in your list. So now that all my data is in L1, I'm going to quit by hitting the second mode button. So we got all of our data in L1. Now it wants me to find the standard deviation. So now we hit second stat. We're going to arrow right until we hit math. If we arrow down in the math column, number 7, STD DEV is standard deviation. So you hit enter. That brings it on your screen. Now you got to get that list that we put in L1. So we hit second stat again. Under names, L1 is highlighted for 1. So I'm going to hit enter. And on my screen, it says standard deviation of L1. So we're going to hit enter and get this answer, which gives me 24.27. So let's see, they're only rounded 1 decimal place. So that's going to be what, a 24.3 for us, which would be C. Okay, y'all, so not bad. Now, if y'all want to do it by hand, someone let me know Monday, and I'll definitely do that by hand, okay? All right, let me pull that down. I'm going to do last question, and that'll be the ending point for this. So this will be 33 we get to, okay? So the scores on the psychology exam were normally distributed with a mean of 55. So that means if I had my little bell curve, that means my mean is 55. And a standard deviation of 6. So my standard deviation, whoops, I don't want to write that there. How about over here? Standard deviation equals 6. So I want y'all to remember this goes to this problem down here, okay? Now, the failing grade on the exam was anything 2 or more standard deviations below the mean. Well, the mean is 55. So they're talking about below is to the left. What they're telling me, every standard deviation is 6. So 1 standard deviation to the right, you would add 6. 1 standard deviation to the left, you would subtract 6. So at 1 standard deviation, 55 minus 6 would be 49. That's 1 standard deviation. But this said 2 standard deviations. So over here at 2 standard deviations, we would subtract another 6 from 49, and that would give me 43. So to the left, you would subtract. If you're going to the right over this way, then you would add 6 and make that a 61 and so on. So remember, these over here are negative standard deviations. So it says the cutoff for a failing score was, well, we got 43. And then you had to remember the chart we had for how much data was within 1 standard deviation. How much data was between 2 standard deviations? How much data was in these tails? Well, remember, 95% of my data falls within 2 standard deviations. So that means these little tails here on each end is the other 10%, right? I mean, the other 5%, because this is going to fill 95% of it. So 5% of your data is in these tails. But y'all, each end ain't 5%. Together, they're 5%. So that means if you're below 43% in this little tail over here, you're half of that 5%, which would be what, about 2.5%. So remember on your test, if you're in these little tails, together they're the 5%, okay? And y'all had a little chart we gave y'all. So go back to your notes and pull that chart out where I listed all those percents, right? Remember, like 68% was within 1 standard deviation, 90-something%, 90-something%, and then your tails, okay? So I'm going to stop us there. So we definitely got at least more than halfway done on this. So I'm going to remember we got all the way to 33. And that was most of your older material. The second half of this test is your newer material. So if you wanted to play with this early, you could. But y'all, what I would be focusing on this week for sure is my chapter 8 and 9 test, okay? This was for your final. So I want y'all to remember your chapter 8 and 9 test has the study guide, which I'm going over the Monday with y'all with. And then you got that test. All right, your final exam that we're going over now, Monday night, we'll finish the rest of this. Final exam will open on December 8th. And the final exam and everything you do in this class will be due by December 12th, Sunday night. So we're getting there, right? All right, so I'll record this. I got it recorded.